Hi, senior high school students. Welcome to Mathenic 05. I am your teacher, Teacher Jessa Valdiviso. This is our second episode in General Mathematics, Lesson 1, Quarter 2, the continuation of Lesson 1. Our topic for this episode is about compound interest. So, compound interest is known as interest on interest. So, for example, if nagkaka-interest si Boy sa akin, hindi niya alam nagkaka-interest din ako sa kanya. Boy, I have here some related questions regarding compound interest before we proceed to the final discussion. The first question is, what do you think is the purpose of a bank? Some of you students will answer, Mom, it is for saving money. Some will answer loan for payment purposes like paying your bills and then for cash withdrawal. So I know some of you have an ATM with you already since you are senior high school student. And then your ATM came from the bank. The next question is, how many of you have been to a bank with your parents? So most of you. Next question, what have you observed when you are inside the bank? So that question is, I know you have answer in your mind right now. So let's proceed if what is compound interest. Compound interest, it is the interest paid on the principal as well as on the accrued interest. So it is usually used by banks in calculating interest for long-term investments and loans such as savings account and time deposits. So students, I want you to remember the word long-term investment. So compound interest is commonly used in long-term investments. Next is it is the interest resulting from the periodic addition of simple interest to the principal amount. So compound interest is very complicated. Kung simple lang siya, simple interest, very easy. In this compound interest, your simple interest will interest. So magkaka-interest is simple interest. And then, I have here the notation and terminology with definition. The first notation is the F. So F stands for compound amount or maturity value. It is an accumulated amount obtained by adding the principal and the compound interest. Second, M. It is the conversion period. The number of times in a year the interest will be compounded. So, conversion period have 4. We have the annually, the semi-annually, the quarterly, and monthly. Annually, our M equals 1. Semi-annually, M equals 2. Quarterly, M equals 4. Monthly, M equals 12. So, remember that 4. Then we have our N. N is the number of conversion period. It is the total number of times interest is calculated for the entire term of investment. That is your N. So later on, we're going to know what is the formula of in solving N. Then we have R. It is the annual interest rate or nominal rate. It is the stated rate of interest per year. Our I is the periodic rate. It is the interest rate per conversion period. And our P is the present value of F. This is the principal P that will accumulate to F if there is an interest at periodic rate I for N conversion period. So for example, if you have 1 million with you, it will it will have an interest later on. So that will called as the present value or the P. Then let's proceed with the example. So we have first, before the example, we have the different formulas in solving the compound interest. So we have the first one, the compound interest. So that is F minus P, or P to the quantity of 1 plus I to the power of N minus 1. And then we have F, that is the formula for F. And then we have the P, the present value, that is the formula in getting the value of P. And our R, that is the formula. And our T, that is the formula. Note, M is equal to MT. In order to get the value of M, we need to have the value of M and your T. And our I is equal to R over M. So this time, we have some example. Example, find the compound amount and interest earned on 25,000 for 1 year and 9% compounded semi-annually. Remember, it is compounded semi-annually. In order to solve this problem, we have two ways in solving this. So first, let's identify the given. We have the P equals 25,000. We have the R equals 9%, or we need to convert it into decimal, which is 0.09. So in getting the 0.099 divided by 100. And then we have our I is equal to R divided by M. So let's substitute. So we have 0.09 divided by 2. So the answer is 0.045. And then our T equals 1 year. And our M equals 2. And our N is M times T. So substitute again. The answer is 2. So this time, let's proceed with the first way of solving the problem. So first is we need to find the value of the compound amount or the maturity value by using the formula. So we have F, or the maturity value, equals P times 1 plus I raised to the power of N. So just substitute value given in the first slide. So we have P 25,000 times 1 plus 0.045 raised to the power of 2. So 25,000, copy 25,000. 25,000 and then 1 plus 0.045, so 1.045 raised to the power of 2, and then 25,000 times 1.092,025, because 1.045 raised to the exponent of 2 is 1.02025. Then the answer is, when you multiply that 1 to 25,000, the answer is this one, 27,300.625, or in two decimal places, 27,300.63. That is your compound amount or maturity value. The second one, because the question is, what is the compound interest? So let's proceed with the question. So we need to use the formula for compound interest. We have I sub C equals F minus P. So we have F, which is 27,300.63, minus our P, which is 25,000. So 27,000 minus 25,000, the answer is 2,300.63. That is your compound interest. Anyway, students, I have here the simple way in solving this problem. This is our second way. So we have second way of solving the problem. It is, in short, we have the IC, or the compound interest, the other formula. By using the other formula, so we have compound interest is equal to P times the quantity of 1 plus I raised to the exponent of N minus 1. So let's substitute the value because it is given in the problem. Our P is 25,000, 1 is the constant, plus our I, which is 0.045, raised to the exponent of 2, which is our N, minus 1, which is constant. And then copy 25,000, then 1 plus 0.045, so 1.045 raised to the exponent of 2 minus 1. So in 25,000, when you multiply 1.045, the answer is 1.092025 minus 1. So 25,000 times 0.092025. So the answer for that, when you multiply 25,000 by that, the answer is 2,300.625 or 2,300.63, which is your compound interest. Very short and easy. So students, we have here problem involving compound interest. So the question is, how much must be invested today in a saving account in order to have 50,800 pesos in 6 years and 9 months? So it is in months, 6 years and 9 months. If money earns 5.4% compounded semi-annually. So let's write the given. So we have our F is equal to 50,800. Our F is our maturity value. R equals 5.4%, or in decimal, it is 0.054. Our I is equal to 0.027. Our T is 6 years and 9 months, so we need to convert the 6 years and 9 months in decimal, in a year. So we have 9 divided by 12, so we have 6.75 years. And then our M is equal to 2. Our N is M times T, so 2 times 6.75, the answer is 13.5. So let's use the formula in computing the present value of F. So we have P is equals F times 1 plus I raised to the exponent of negative N. So again, let's substitute the given value. Our F is 50,800, then copy the 1 which is constant, plus I 0.027 raised to the exponent of negative 13.5, which is our N. So we have first compute the inside. We have here copy 50,800 and then 1 plus 0.027. The answer is 1.027 raised to the exponent of negative 13.5. So when you multiply that one, the answer is 35,453.79. So that is our now present value of F. So I hope you follow and understand this given problem. So this time, it is your turn to answer this question. So we have here your problem. So answer the problem below. So first, Kenneth borrows 100,000 and promised to pay the principal and the interest at 8% compounded monthly. Remember, it is compounded monthly. The question is, how much he must pay after 5 years? So it should be paid by 5 years. So I hope you will answer that one in your houses. So this is the end for this episode. Thank you so much for watching and following my discussion. So students, once again, this video is for supplementary learning delivery mode for learners amidst COVID-19 of Pangantucan National High School. Thank you so much and God bless us all.